Finding the surface area of a cuboid it can be a little bit troublesome sometimes if you don't know the formula. But to show how the formula is created, if we just have a look at this first rectangle, 4 times 6, well, there are two of them. There's one at the front and then there's one at the back. So there are two of the green ones. There are two 4 times 6s. And what about a different surface? The top. So the top surface, that is 5. This length here is 5. And this length here is 6. So there's one on the top here and one on the bottom down here as well. So there are two, which is 5 by 6. 5 by 6. And there's a third, which I haven't done yet, which is along this side. And that is 5 by 4. And there's one on this side and there's one on the back. So there are two 5 by 6s. Oops, 5 by 4, sorry, 5 by 4. And that is all the different surfaces added together. And you may be able to spot that if you take a factor of 2 out of here, you've got a 2 here and here and here, then you've got 2 of these ones and these ones and these ones. But if we, instead of referring to this as 4 and 5 and 6, we just call it A, B and C. Let's call that one A, that one B and that one C. Well, this one was a combination of A and B. So there were two A times B's. And there were two B's times C's. And there were two A's by C's. And we could simplify all of this to just make the formula two lots of. We can write A times B as just AB, B times C as BC, and A times C as AC. And this is the formula for working out the surface area. So in this case, if I were to multiply all these together, in the original equation, I'd find that the area is 148 centimeters squared. In this case, it's asking for the area of a cylinder. So a cylinder is a shape that has the circle at the top and the bottom, and it's connected with a curved rectangle. And if we unwrapped this curved rectangle to make a normal rectangle, then you've got one circle at the top, one circle at the bottom, and it's all connected with this rectangle in the middle. But the length of the rectangle is the same as the circumference. So the outside of the circle here, all these points around the outside of the circle have to connect with all the points along the edge of this rectangle. So they are the same length, which means that the circumference of the circle, which is 2 pi r, is the same as that length there. So that yellow length is also 2 pi r. And therefore the area of this rectangle could be calculated using the circumference of the circle. So by reviewing the question again, it says that the circle has a radius of 3. So that must mean that the circumference is 3 times 2 times pi, which is 6 pi. That means in this rectangle, that length is 6 pi. And the height is 10. So that length is 10. And to find the total area, the area of the rectangle would be 10 times 6 pi, which I will leave as 60 pi. I'm not going to do that into a calculator because I don't want to do my approximations too early. And then I want to add the two circles. So the area of the circle, and I'd write 2 here because I have two circles, would be 2 pi r squared. And the r I know is 3, so that's 3 squared. So that's 9 times 2 is 18. And then the area total would be these two added together, which is 78 pi. I would read the question again just to see if it's asking for it in any specific significant figures or anything, and if it hasn't got anything like that, I could leave my answer like this with centimetres squared. But if I wanted to write that to 2 decimal places or something, I would write equals 245.04 centimetres squared, but I'd have to write in brackets after that 2dp because it's not exact. Okay, have a go.